Hello everyone, welcome to my channel Vidyarthini's Academy of Computer Science, Learn with Passion. In today's video lecture, we'll be seeing about system calls in operating system. And before we get started, if you like my video lectures, please do like, share and subscribe to my video lecture. And don't forget to press the bell icon. And let's get started. In this session, we'll be seeing about system calls. First, let's see the session content. It is what is system calls in operating system. First thing we will be learning about this one, and then we'll have an example for system call and how did the system call work. We'll see about that, and types of system calls. What are the types of system calls that are there, and the rules for passing parameters for system calls and important system calls used in operating system. These are the things which we will be covering in this session. Yes. What is a system call in operating system? System call is a mechanism that provides the interface between process and the operating system. What is a process? Process is nothing but the program in execution. When a program requires something from the OS, it has to send a message to the OS, and that is called a system call. A system call is the mechanism that provides the interface between process and the operating system. Process and the operating system should communicate, right? And this is the mechanism through which these two, process and the operating system, can communicate. So system call is a mechanism that provides the interface between process and the operating system. So it is a programmatic method in which a computer program requests a service from the kernel of the operating system. System calls offers the services of the operating system to the user program. So system call is the one which offers the services of operating system to the user program, and through an interface called application programming interface. So system calls are the only entry point from the kernel system. So system calls are the only way through by which a user program can communicate to the operating system. So next slide. In this slide, you will be seeing the pictorial representation of a system call, how it works, how it is connecting to the operating system. So let's see. A user program is there. You are sending a request. You're using the user interface, application programming interface, sending the system call, and these are the system calls that you can send to the hardware, that is the operating system, to the hardware, and that is, you will be communicating to the operating system and getting the information from the resources of operating system. So I'll just zoom this picture. Can you see now? Yeah. This is the pictorial representation of how system call is in the, using the operating system. Yes. Next is an example of a system call. Yeah. So let's see. Let's take an example of copying a content from one file and writing that content to the other file. So what are the things that we require for this function? In order to write a program code, you have to read from one file and you have to copy that into another file. First, you have to give two informations. What are they? Name of the two files, that is input file and the output file. The file from which you are going to take the information, that is the input file, and the file in which you are going to write, that is copy the information, that is the output file. So you have to get the name of two files. In an interactive system, this type of program execution requires some system calls by the operating system. First call is to write a prompting message on the screen. So when you open a file, it will be either showing the list of files available, or you have to type the name of the file which you have to open. And second, to read from the keyboard the characters which defines the two files. Either you have to type it or you have to select it. So it is getting the information by which we are typing it. So it is getting the information from us through the keyboard. And next is how system call works. Here are the steps for system calls in operating system. This is the architecture of the system call. How it works, let me zoom in the picture for you. Yeah, There are two modes actually, user mode and kernel mode. In user mode, user program execution is happening. That is, you will be telling the file to the file that has to be opened, get the system call, that is open this file. You're giving a system call. Then it just goes to kernel mode from the user mode, execute the system call. It will accept that system will be OS will be accepting the system call as to open this particular file, and it will get executed, and it will return to the user mode based on the system call that you have sent. So this is the architecture of system call. So as you can see in the system call explanation diagram, the process executed in the user mode till the time a system call is interrupted. So till the time there is a system call, it is executed in the user mode. Once the system call is sent, that is open file, for example, it just goes to the kernel mode. After that, the system call is executed in the kernel mode on a priority basis, and once the system call execution is over in the kernel mode, the control is again returned to the user mode. So the execution of the user processes resumed in kernel mode. So next slide. Why do we need a system call in operating system? The following are situations which need system calls in operating system. First thing, reading and writing from files demand system call. You have to open a file, take some data and write into another file by copying that data. So reading and writing from a file demands system call. If a file system wanted to create or delete file, you are just creating or either deleting a file, system calls are required, and system calls are used for the creation and management of new processes. If either you're creating a new process, that is you are adding some more data to the already existing process, that also is requires a system call. And network connection needs a system call for sending and receiving packets. You are sending some data through a network, through either, say for example, through internet. For that also you are sending a system call. Access to hardware devices like scanner, printer needs a system call. In order to you are giving a print command to a printer, that is also a system call. So these are the reasons, these are the situations in which system calls are used in operating systems. Next, let's see the types of system calls. Here are the 5 types of system calls in operating system. First one is process control, second one is file management, third one is device management, information maintenance, fourth one, and fifth one is communication. These are the types of system calls. This is the diagrammatic representation of types of system calls in operating system. Process control, file management, device management, information maintenance, communication. So types of system calls. So first type of system call, process control. This type of system call performs the task of process creation, process termination, etc. The running program has to complete it either normally or abnormally. The normal termination, normal completion of the program is called end, and abnormal termination is the abort. So this is the first function of process control, and load and execute the program. Then create process and terminate process, get process attribute and set process attribute, wait for the program, that is wait until some action is performed, wait until the child process completes, and then you can proceed, the parent process can proceed. For example, I'm saying, so those are the system calls under a process control. Wait and signed event, allocate and free memory. Once the process is completed, it can free the memory. So these are the functions of the system call process control. Next, file management. In this file management system call handles file manipulation jobs like creating a file, reading and writing a file, etc. The following are the functions such as creating a file, delete a file, open and close the file, read, write and reposition. That is, you are copying some data from a file and writing it to another file, or you are just altering the content of the file, or you are getting get and set file attribute. That is, you are just changing the name of the file, or taking the file, cutting the file from one location and pasting it into another location. So these are the file operations and the functions under file management. Next is the device management system call. Under this device management system call, it does the job of device manipulation like reading from device buffer, writing into device buffer, etc. The following are the functions of device management. It requests and releases a device, a read, write, reposition, logically attached or detached devices, get and set device attributes. So device in the sense what it can be either physical devices like tape drives, or printers, etc., or virtual or abstract devices like file. So these are the following functions that the device management system call performs. Next is the information maintenance system call. It handles information and its transfer between the operating system and the user program. And the following are the functions of information maintenance: get or set time and date, get or set system data, get process files or devices attribute, set process file or device attribute. So these are the functions of information maintenance system call. Next is the communication system call. These type of system calls are specially used for inter-process communication, and the following are the functions of a communication system call: create, delete, communication connection, send, receive message, help OS to transfer status information, attach or detach remote devices. So these are the functions under communication system call. Next is the rules for passing parameters for system calls. There are three things under this. Here are general common rules for passing parameters to system call. So let's see each of that. Parameters should be pushed on or popped off the stack by the operating system. So this is the stack. One method is using the stack. The next one is parameter can be passed in register. So if there is a parameter, you can pass it in the register. And the third one is when there are more parameters than registers, it should be stored in block, and the block address should be passed as a parameter to the register. The third one is if there are more parameters, you have to store it in a table or block in the memory, and you have to send that address of the block as in the register as a parameter. So there are three things: either you can send the parameter in the register, or you can use the stack method, or you can store all the parameters in the block or table. Then you can use that address of the block and send it as a parameter in the register. So these are the three general rules of passing parameter for system call. System call provides the interface between a process, that is the running program, and the operating system, as we all saw this. And generally it is available in the form of assembly language instructions sent in the form of macros and subroutines. So thus the three methods which are used for passing parameter are pass parameter in register, or pass parameter in the form of table that is stored in the memory table, and the address of the table is sent in the register, or push the parameter onto the stack by the program and pop off the stack by the operating system. So these are the three methods in which parameters are passed in the system call. So this is the diagrammatic representation of the system call passing parameter on a table. So x parameter is being called, and the load the address of the ax, and it is address of the ax is stored in the register, and that gets used in the operating system. Use parameter from the table X. Code for the system call, the system call 13, and there will be code for system call 13 in the operating system. So this is the diagrammatic representation of system call passing parameter as table. So let's see next. Register, it has a register, and the register will be having the address of the table, parameter stored in block or table in memory, and address of the block passed as a parameter in register. Register, either it uses the language Linux and Solaris as shown. Parameter placed or pushed onto the stack by the program, and it is popped off the stack by the operating system. Blocks and stack method do not limit the number of length of the parameter being passed. So what do they say? When there is only one parameter, you can place the parameter directly into the register, but there are when there are a number of parameters, it is always best to store it in a table form and send the address of the table, or you can use the push and pop method, which doesn't limit the number of parameters to be passed. Next is the important system calls used in operating system. Under important system calls used in operating system, we'll be seeing about wait system call. In some systems, a process need to wait for another process to complete its execution, and this type of situation occur when a parent process creates a child process, and the parent process has to wait until the child process completes, and once the child process is completed, the execution goes back again to the parent process. So the suspension of the parent process is caused automatically and with the help of wait system call. When the child process ends execution, the control moves back to the parent process. So this is the situation where the wait system call is being used. Next is the fork system call. Processes use this system call to create processes that are a copy of themselves. With the help of this system call, parent process creates a child process, and the execution of the parent process will be suspended until the child process is executed. So next is the exec system call. This system call runs when an executable file in the context of an already running process that replaces the old executable file. However, the original process identifier remains as the same, but the stack data, head data, etc. are replaced by the new process. Next is the kill system call. This kill system call is used by the operating system to send a termination signal to a process that urges the process to execute. It is forcefully coming out of the process. However, a kill system call does not necessarily mean killing the process, and it can have many various other meanings. So it is like forcefully coming out of the process. That time we use this kill system call. And exit is proper termination, that is proper way of completing the process and coming out of the process. So this is used in multi-threaded environment. So let's see that the exit system call is used to terminate a program execution, especially in the multi-threaded environment. This call defines that the thread execution is complete, that is proper completion of the thread, and the resources will be given back to the operating system. That is, the OS reclaims resources that were used by the process after the use of exit system call. So that's all. So these are the few examples of system calls which are important, and this is the summary of the categories of system call: the process control, device manipulation, file manipulation, information maintenance, communication, protection. So these are the categories of system call, and how it is how it is used under Windows, how it is used under Linux, the comparative study of the system call used in Windows and Unix, and in next slide you will have the system calls of Linux. That is, we saw about fork, exit, wait, open, read, and all. No, so these are the system calls used in Linux. Important question under this system call topic are what are system calls, what are the categories of system calls. They can ask you either separately or together as one question. Also they can ask what are system calls, what are the categories of system calls, explain in detail. So that is the possible question under system calls topic. So that's all for this session. My next session will be in operating system programs. Thank you. And if you like my video lecture, please do like, share and subscribe to my channel, and don't forget to press the bell icon. Thank you so much.